Hi everyone, this video is for lesson 17, which is a triangle and its angles. So we are going to start this lesson talking about some very general facts about the angles of a triangle. So the first fact that is super important, and this is the fact that we always come back to within this class, is that the sum of the angles in a triangle is 180 degrees. So that's talking about the interior angles in the triangle. So for instance, that's like this angle here, if I were to call this angle A, this angle B, and this angle C. So the thought behind it is that those three angles, when I add them up, they must always sum to 180 degrees. Okay. Now it doesn't say that it has to be the same measure. They could be. They could be different measures, so on and so forth. With this idea, we also include right triangles. So when I have a right triangle, I know that one angle and only one angle can equal 90 degrees. But what I also know is that the other two angles, if I label it D and E, their sum together must equal 90 degrees as well. So this leads us to this statement here. When one angle of a triangle is a right angle, the sum of the other two angles is 90 degrees. Okay, so what I can then say is that for here, move this up, the measure of angle D plus the measure of angle E has to be 90 degrees, and that's because I already have a right angle right here. So these are just two facts that we are going to constantly come back to, and we should be able to recognize quite easily. So with that being said, here is a great example. Now this is dealing with a triangle and the angles of a triangle. So we know that that 180 factor comes into play right off the bat, right? The angles have to sum to 180. But now they're in a ratio. And it says the ratio is 8 to 3 to 4. So they want the smallest angle. So first thing is, I mean, if the three angles are 8, 3, and 4, well, let's just like think about this, right? So they're just giving us 8 to 3 to 4, and we have to like form some sort of triangle. So just make like a triangle like this. And say what kind of triangle. And think about this. If I put an 8 here, so they tell me 8, a 3 here, and a 4 here. Well, these three numbers do not make sense to represent the angle measures in this triangle, right? Because 8 plus 3 plus 4, well, that's 15. And I know that the angles have to sum to 180. So it doesn't make sense to say that 8 plus 3 plus 4 is 180. Now, they use this word, it's in a ratio. So when you compare things in a ratio, it's really the simplest form of comparison. So for instance, 8 to 3 to 4, another pair of numbers that could be put into a ratio of 8 to 3 to 4 could be 16, 6, and 8. Because when I simplify them down, it's 8, 3, and 4. So in our class, whenever you see the term ratio, you should be thinking to be putting an X. Put an X next to each one of those numbers. So what I really have here now is 8x, 3x, and 4x. And what did we say? Well, we said all three of those angles have to sum to 180. So I know, bring this down here, based on this ratio, I can say 8x plus 3x plus 4x equals 180. Okay, and then just combine my terms. 8x, 3x, and 4x is 15x equals 180. Divide by 15, right? And then x is equal to 12. So now we have x, but we need to figure out what's the smallest angle. So now that we have x, we can substitute this right into here for x. Here, here, and here. So what I really have now is 8 times 12, 3 times 12, 4 times 12. I have to figure out the smallest angle. So here, this is going to be 96, right? 8 times 12. 3 times 12 is 36. And then we have 4 times 12, 48. So our smallest value, I think it's pretty clear, it's right here, 36. So the smallest angle is 36. Okay. So again, when we have that ratio, it just means you put an x next to each piece and then begin to solve. Ratios come up all the time, so please make sure you have that kind of ingrained now. Ratio, put an x. Okay, moving on. Let's do something like this. So I like this question because we're asking you to find the measure of both angle x and angle y. So here and here. And most of the time, students say, well, finding angle y is so easy, right? Because 40 plus y, they're a linear pair, and so they have to equal to 180. So that's easy to say then that y must equal 140. So I'm going to type in here, right, we have 140 for y, done. Okay, easy. Y is 140. Now, x really isn't too bad either, right? Because x, 75, and 40, these are three angles in a triangle. And the angles in a triangle must also sum to 180. So that's x plus 75 plus 40 equals 180. Right, so then for this, if we combine like terms and we subtract, we actually get that x is equal to 65. So here, x is 65. Okay, so not bad. We were able to find angle x and angle y, linear pairs, and angles in a triangle sum to 180. Excellent. Now look at the follow-up question. What do you notice about the measure of angle BCD? So just to reiterate, if we have to find angle BCD, that's the angle from B to C to D. It's right there. And it's this measure right here. And we're not asking you to say that it's an obtuse angle. That's not really what we're asking you to say. When we say, what do you notice about the measure? It's, can you make a relationship, right? It's 140 degrees. How else, or does something else sum to 140? And what we're really focusing on is this over here. Take a look at these two angles, 75 and 65. Now the thought is, if I add 65 and 75, that actually gives me 140. Now these are interior angles because they're inside of the triangle. This here is an exterior angle. It's outside of the triangle, right? This is an exterior angle. These three are interior. This is exterior. So what do we notice? We notice that angle BCD is the same as adding angle BAC and angle CBA. We can get that same sum. All right. So the cool thing about this is this right here leads us to our exterior angle theorem. So first I'm going to ask you to copy this down. So pause and copy, and then I'm going to go ahead and explain. So what does the exterior angle theorem state? It's really quite cool. No matter what kind of triangle you're dealing with, as soon as you get an exterior angle, which if you take a look over here, angle 1 is our exterior angle. So let me go ahead and label that. Angle 1, this is our exterior angle. So once you extend the side of the triangle and you create an exterior angle, we have three other interior angles. And the cool part is that the two angles that are furthest from your exterior angle but are inside the triangle, their sum will always equal to the exterior angle, which is why it's known as the exterior angle theorem. So, do this. These two values, 2 and 4, When I add 2 and 4, I'm going to get angle 1. So these are your non-adjacent or remote interior angles. So if you add those two up, they're equal to that exterior angle. And again, right now it's probably like, what is she saying? This is so confusing. Once we actually put some numbers into this, it becomes a little bit easier. Okay, so I always do this. If I see this diagram, I say to myself, okay, well, here are my two remote interior angles. If I add them up, it equals this one right here. So I can write a little statement. My statement can say that the measure of angle 1, my exterior angle, is equal to my two non-adjacent interior angles, which is angle 2 and angle 4. So, okay. The big thing that you want to take away from this right here, this is the exterior angle theorem. So you see this diagram, and I'm thinking this. We call these angles like remote, opposite interior, but they're your interior angles that are on the opposite side. 3 is adjacent to 1. We want the non-adjacent angles, okay? So how does this work? Take a look here. Okay, so here's my diagram. First thing I see is a triangle. I don't have all 3 angles, but I notice this angle here is an exterior angle. So that's going to be my first thing. This is an exterior angle. So that means that I can use the exterior angle theorem. That says that the exterior angle is equal to the two non-adjacent remote angles. Well, here they are. So if I add up my remote interior angles, they're going to equal my exterior angle. So we have an equation. Your exterior angle is equal to your two non-adjacent interior angles, 42. Okay. And once you have an equation, we know we can use algebra to solve, right? Subtract 42 from both sides, and we find that A is equal to 36. That's this here. Okay. One thing that is not true, this is not a 180 problem, right? We cannot say here that 42 plus A plus 78 equals 180. Okay? This is not that problem because 78 is not inside the triangle. So this is a big old no. Can't do that. Get that out of your head right now. Okay, so let's continue on and let's see number 2, what this looks like. So find the measure of the exterior angle. So we have to find this angle here. This is our exterior angle. So your exterior angle is equal to your two remote interior angles added up. So if I add these two up, it equals this angle here. So what does this look like? Well, it looks like this. Our exterior angle is an expression is equal to our two non-remote interior angles added. Perfect. And now we just go ahead and we solve, right? We have to find the value of x. I'm going to draw my line down the middle. I could bring down the 3x minus 10. Combine like terms, so x and x is 2x. 34 and 6 is 40. And there we go. It worked to get x alone, so I'm going to subtract my smaller variable, the 2x. Here we go. And now we have 1x minus 10 equals, these cancel, 40. Okay. Add 10 to both sides. And we get that x is equal to 50. Okay, but this isn't the final answer, right? Because it specifically says it wants the exterior angle. We said here, this is your exterior angle. Right now it's an expression. It's 3x minus 10. So to find the exterior angle, which is 3x minus 10, we have to substitute. We have to take x equals 50 and plug it in. So plug 50 in for x. That's how we're going to find the exterior angle. All right, let's do that. We're going to do 3 times 50 minus 10. So 150 minus 10 is 140. Here, the exterior angle equals 140. And that is your final answer for this problem. Okay, so again, exterior angle theorem. This angle is equal to the sum of the two remote interior angles. Okay, so let's move on now and talk about the different types of triangles. We've already discussed an equilateral triangle in length during construction, but we also said when it has 3 equal sides, it also has 3 equal angles, which means it's also an equiangular triangle. So here's a diagram for a triangle that is both equilateral and equiangular. So the arcs show that your angles are equal. The tick marks show that your sides are equal. Remember, when you have an equiangular triangle or an equilateral triangle, each angle is 60 degrees. Here, they all equal each other, and all the sides are also equal in length. I know that each angle is 60, kind of based off what we just said before, that general fact that if all triangles sum to 180, right, all the angles, and each angle is the same, I divide by 3, that's where we get that each angle is 60 degrees right there. Okay, now a scalene triangle. I don't know if you remember about a scalene triangle, but a scalene triangle is a triangle with 3 unequal sides. If there's 3 unequal sides, there are also 3 unequal angles. So here you can see that given these lengths of 3, 7, and 9, they're all unequal, therefore it's a scalene triangle. This is how you classify triangles, right? Scalene, isosceles, equilateral, equiangular. These are classifications. Okay, then moving on, we have an isosceles triangle. So the isosceles triangle is a triangle with at least 2 equal sides. So it's interesting because it says at least 2 equal, which means technically if a triangle has 3 equal sides, it's equilateral, but that means it's also isosceles. So if you take a look here, here's our diagram, and we have that AB equals BC. So we should be able to mark that AB and BC are equal. Now, I'm going to go ahead and further explain the isosceles triangle by identifying some of its parts. So here are the equal sides. I'm going to mark the equal sides down here. And in an isosceles triangle, the two sides that are equal are known as the legs. So this is a leg, and as is this right here. So the equal sides are the legs. Now the unequal side is known as the base. Many times you think the base is the bottom, but actually the base could be any side of the triangle. It's just the side that's not equal to the other two. So here's the base right here. Now, what's interesting about the isosceles triangle is you have equal sides, you also have some equal angles. So to figure out where those angles are, I think of like this marking as an arrow. This leg points to its angle that it's across from. This leg points to its angle that it's across from. So take a look. This leg is opposite this angle. So I'm going to put a mark here. This leg, which is the same size, is opposite this angle. So I'm going to put the same mark here. So actually, these two angles are actually equal. And notice that these two angles touch the base. So these two angles in the isosceles triangle are known as base angles, and they're equal. So we're going to write here, base angles. They're equal. All right, so here we have that. So they're base angles and they're equal. Now you have this angle up here. Well, this angle that's not equal to the other two is known as the vertex angle. There you have it. Okay. So based on having an isosceles triangle, we can actually form a lot of different theorems. So here's one theorem. Actually, we'll do the theorems and I'll go back. If two sides of a triangle are congruent, well, if we have two equal sides, we also have two equal angles opposite them. So here are equal sides, and then I go across. Here's one equal angle. Go across, here's the other equal angle. Now, if I take this theorem and I flip it around, meaning if I take this part first, if I talk about having equal angles, I also have equal sides. So this angle would shoot across to this side, and this angle would go across to this side. So the converse, taking this theorem and flipping the order, states if two angles of a triangle are congruent, the sides opposite them are congruent. Okay, that's known as the converse. Okay, now I'm going to just go back because I skipped this here. This is the construction. It says to construct an isosceles triangle with AB as a leg, so I'm just going to write here leg, AB has to be a leg, and CD as the base. So based on what we know about an isosceles triangle, there's one base and there are two legs, right? Two legs, one base. We are going to start this construction with the base. So I have to copy this base onto a red. All right, so I'm going to take my compass and I'm going to measure from C to D, the base. And I like personally to make the base the bottom. So C to D, swing an arc to show I measured. Go from here to here. Perfect. And with a little point. I'll make the point blue. Right there. Okay, here's the base. Now I need two legs. And think about how we did the equilateral triangle. You measure the length that you need the sides to be. So I'm going to go from here to here. And if it's a triangle, it's going to intersect somewhere up here. So I'm going to use the endpoint. I'm going to swing an arc up here. Right, there it is. Perfect. I'm going to flip it around, go to the other endpoint, and I'm going to get my other arc up here. Perfect. And now I'm going to connect to make my triangle. Here to here, and here to here. And I just constructed an isosceles triangle. And the legs are equal. Base angles would be equal. And then we have our vertex on top. So I wanted to actually do this all like this. And there you go. Okay. Remember, this is a video. Pause, rewind, do whatever you need to make sure that you're following along. Okay, so we did the theorem. We talked about the converse, right? And now let's go on to the right triangle. So right triangle is pretty unique. A right triangle, we know for sure that it only has one angle that's 90 degrees. So you take a look here. At angle B, we have this little box. So that tells us that angle B is 90 degrees. That also tells us that angle A plus angle C must equal 90 degrees as well. Now, there are different parts of a right triangle, just like there are different parts of an isosceles triangle. So in a right triangle, you obviously have a right angle. So here it's pretty obvious that this is my right angle. The one side that's really important to be able to identify is the side opposite the right angle. So if this is the right angle, the side opposite the right angle is known as the hypotenuse. That's the side here. And I don't know if you remember anything about the hypotenuse, but what we know is that the hypotenuse in a right triangle is always the longest side. If you think back to potentially Pythagorean theorem, the hypotenuse was like your C in Pythagorean theorem, which is a squared plus b squared equals c squared, it was always the longest side. Now, the other two sides that make up the right angle are known as the legs. The leg here and a leg here. Now, it's different because in an isosceles triangle, the legs were equal. But here's the key. In a right triangle, the legs do not have to be equal. They might be, but they don't have to be, okay? That's really, really important to know. And again, you know you have a right triangle when clearly you have a right angle. Okay. So here we have this right here. All right, so it's our right triangle, the legs, the hypotenuse, and our right angle. Okay, let's continue on to an obtuse triangle. And this triangle only has one angle greater than 90, but less than 180. So if we have something like this, it's clear to see that angle B is obtuse. Therefore, we can kind of put a value at 130 perhaps for angle B. Clearly, this is an obtuse triangle. So when it has one obtuse angle, it's an obtuse triangle. Now, for an acute triangle, it's different. All of the angles have to be less than 90 degrees. So take a look over here for our acute triangle, right? Each of my angles are less than 90, greater than 0, of course, but that then classifies it as an acute triangle. And there we have that. All right, so let's take a look at this question here, number 3. We have triangle ABC. Angle B is 62. AC is tends to D. What value of x would make AB congruent to CB? So first, I'm going to assume, if I need to make them congruent, that I want AB and CB equal. And if AB and CB are equal, well then this angle and this angle have to be equal. Okay, so x is already used. Let's make this angle y. And this is angle y. This has to be angle y. Okay, now let's try to figure some things out. I have a triangle, and the angles in a triangle sum to 180. All right, so now I can write an equation. My equation is going to take the interior angles of my triangle, which is y, 62, and y, and set it equal to 180. All right, so now I have 2y plus 62, right? Because y plus y is 2y. And if I want to solve for y, I need to subtract 62. So I get that 2y is equal to 118. And then I need to divide by 2. And y is equal to 59. Okay, so I know I have 59 as my angle here, right? And it's also this value here. Now to get to x, well, I have y. These two angles form a linear pair. They're 180. So I could create another equation. 59 plus x equals 180. And if I subtract 59 from both sides, I know that x is 121. And that is how you find the value of x. Now, are there other ways to do this? Of course. I'm just doing the way that I see is the most direct that you may see as well. Okay, so this one right here. So let's look at another example. We have a triangle, and we have that this triangle, ADB, is equilateral. That means it's also equiangular. And then this triangle is isosceles with these equal sides. Okay, so first let's deal with the equilateral triangle. ADB is equilateral. That means that each angle is 60 degrees. Done. Check. Equiangular, equilateral, same thing. DB is congruent to BC. So that means that this triangle over here is isosceles. That means that this side is across from this angle, and this side is across from this angle. Okay. So in this triangle, DBC, I don't know any of the angles, but I know that these two angles have to be the same because it's isosceles. Well, maybe I can solve for this angle here. These two angles have to sum to 180 because they're a linear pair. So this has to be 120 then, if together they have to add up to 180 to form a linear pair, right? And now within my triangle, I take a look. I know that if this is x, this is 120, and this is x, all three have to sum to 180 because they're the interior angles of a triangle. That means that I have 2x plus 120 equals 180. And if I subtract 120 from both sides, I get that 2x is equal to 60. Divide by 2, x is 30. Well, if this is 30, and this is 30, and that means that the measure of angle C is then 30. So I found my answer. Measure of angle C equals 30. So here I use my equilateral triangle, my isosceles triangle, a linear pair, and the angles in a triangle sum to 180. All right, let's go on to number 5. This says that we have 3 angles at 100 degrees, 50 degrees, and 30 degrees. So let's get that in first. So A is 50. BDC right here is 100. Okay. And DBC up here is 30. I need to figure out which of these statements is true. Okay, so before I do anything, I'm going to work to solve for all my missing angles. Once I have the angles, everything else should be pretty easy. So I'm going to look over here, and I see a triangle. So I have 2 of the angles. All 3 should add up to 180. So if this is 100, this is 30. That's 130. This then has to be 50, right, to get to 180. Excellent. These are a linear pair. So if this is 100, this has to add to 180, so this has to be 80. Good. And now we have over here another triangle. So using that same thought process, these 2 angles plus this third has to equal up to 180. So 50 and 80 is 130. So that means that this all has to be 50 up here as well. Okay, let's go through our choices. A, B, D is obtuse. So A, B, D. So this triangle. Well, that's not true because no angle is greater than 90, so no. A, B, C, the big triangle, is isosceles. Well, I have 2 equal angles, 50 and 50, so I'm thinking yes, but let's go through everything else. A, B, D, so this angle up here, is 80. Incorrect, it's 50, so no. And then ABD is scalene, which no, because these 2 are 50, so that would make it isosceles, so no. So yep, choice 2 is our answer. And there it is. Okay? Again, when you fill in all the missing angles and you use that relationship, it becomes quite easy to then go back and compare. All right. Oh, so that was it. So that was the last question for lesson 17. With that being said, you now have some practice questions to complete. So if you have any questions from this lesson, please feel free to email us or contact us through our Google Classroom.